Good day, students and viewers. You are welcome to the studios of Maths X. We are still on sets, my dear students and viewers. Previously, we talked about types of sets. I trust you've been thoroughly enlightened on the types of sets in mathematics. In today's class, we will be treating the operations involving sets, and that is operations on sets. You will find this particular class very interesting as these operations are unique to sets. They don't occur in our regular algebra or arithmetic, as in those parts of mathematics do not have these. So these operations are unique only to sets. You will find this class very, very enlightening. Happy viewing. The first operation involving sets I want us to talk about, my dear students and viewers, is called, number one, is called the union of sets. For union of two or more sets is a combination of all the elements in the sets without repetition. So we will say that this is a collection or combination of all the elements in two or more sets without any repetition. The symbol of union of sets is, so its symbol, it looks like a U. So that is the symbol for union of sets. To explain union of two or more sets, if I have a certain three sets, for set A, first of all, I have 1, 2, 3, 4. I have set B, which is 2, 4, 6, 8. And then a third set, C. Set C is 1, 3, 4, 7. So I will say, for example, our first example is find A union B, and then the II will be A union B union C. Let's start with the I first. To get my A union B, my A union B will be 1, 2, 3, 4 union the next set, which is 2, 4, 6, 8. Now, we said that this is a collection of all the elements in two or more sets without any repetition. That's what we said. So let's look at this. So our A union B will be a set. 1 is here, 1 is not here, so 1 is there. 2 is here and 2 is here. We said without repetition, so we'll take only 1, 2. 3 is here, 3 is not here. We take 3. 4 is here, 4 is here. We still take one of the 4s. This set is gone. Let's check this other set. There's 2 and 8 unused. So this is our A union B. Let's look at A union B union C. For A union, this is the II. For A union B union C, this will be a set. So we have 1, there's 1 here, so 1 is a member. We have 2, that's a member. there's 3 here, but there's no 3 here, so it's also a member. 4, 4, and 4. They say no repetition, so we will take only one 4. There is a 6, a 7, and an 8. So that is a 6, 7, and 8. So this is A union B union C. That is for union of sets. Let's go to the next set operation, which is the intersection of sets. For our intersection of sets, the intersection of 2 or more sets is another set which contains elements common to the 2 or maybe even 3 sets. So I'll put that down, that the intersection of 2 or more sets is another set which contains elements common to the previously mentioned set. So I'll take it again, that the intersection of 2 or more sets is another set which contains elements common to the previously mentioned sets. So that is it. So I'll still cash in on these sets A, B, and C. So I have to take off this part of the board. So once again, we still have set A, B, and C containing these elements. So we're going to say, for our example, we will find I, first of all, or rather I, A intersection B, then I will find A intersection B intersection C. So for our solution, first of all, the I part, A intersection B, we said elements that are common, right? So look at this. For our sets A and B, what is common? 2 is common and 4 is common. There's 2 here and there's 4 here. So 2 and 4 are the only common elements. So our A intersection B is a set 2, 4 rather. Then also I, for our A intersection B intersection C, what do we have on that? We have a 1. There's no 1 here, right? So it's not common, but there's 1 here. So 1 is not common to 3 of them. Let's look at 2. There's 2 here, there's 2 here, but there's no 2 here. Let's look at 3. There's 3 here, no 3 here, but there's 3 here. It's not common. But how about 4? 4 is common. So then there is this set A is done. There's 6 here, there's no 6 here, no 6 here. 8 here, no 8 here, no 8 here. Then 7 here, no 7 here, no 7 here. I already had my conclusion. So it's just 4. Having done this for my intersection of sets and union of sets, I will want to express this. I will want to express these expressions in Venn diagram form, because it's very important. Most of my students do tell me that for sets, Venn is the main expression for solutions in sets. So let's put together a Venn diagram to this effect. So here we go. We have our Venn diagram. I told you it was named after its inventor, the person that brought it to being. His name was Venn. Can't recall his first name anymore now. We have A, B, and C. So the intersection of 3 of them is a 4. All right. So for A intersection B, what we have is 2 and 4. So that is, there's a 2 here because 2 and 4. Let's look at it now. A intersection C, there's a 1, 1. So there's a 1 here. And there is also a 3. So 1, that's 1 and 3 for A intersection C. Let's do B intersection C. For B intersection C, all that is common for them is 4, all right? And we have a 2 here. Then there's a 6 and 8. Let's write it separately before you think it's 68. It's not 68. So that is it. All right. Then for C, 7 is remaining. So there's 7 here. All right. Then for A, that is 1, 2, 3, 4. So 1, 2, 3, 4. So everything about A is done. This is Venn diagram representation. So for this, we have here the intersection of A, B, and C, which is your 4. This is the intersection of A and the intersection of A and C would be 1, 3, and 4. All right. So the intersection of B and C will be 2 and 4. And that is it. So this is Venn diagram representation of your A intersection B intersection C, which is this particular location. All right. So then, of course, your A intersection B, which is this particular location. If I should do that shading that way, so please do not be confused. So that is just what it is. So this is your intersection of A, B, and C. This is your intersection of A and B, which I did earlier. That's 2 and 4. That's your 2 and 4. So that is your Venn diagram representation of what I just did. My dear students and viewers, this is it for set operations to ensure that you are properly grounded when it comes to operations involving sets in mathematics. My dear students and viewers, do keep watching the videos of Maths X, like, share, and do not forget to subscribe to our videos. As you do so, God bless you. Thank you for your time.